Good morning, everyone. Jaswinder, very good morning. Sorry for delay. I was having a continuous class due to revision of grade 9 10 students. So, we are doing coordinate geometry. In coordinate geometry, we have discussed first the distance formula. Then we have discussed the midpoint formula. Then we have discussed distance from the origin, distance of point from the origin of a point from the origin. And today we will discuss about section formula also. Section formula. Right? So distance formula we have discussed two points A, B, then the straight line distance between them, that is equal to x2 minus x1 whole square and y2 minus y1 whole square. Right? x2 minus x1 whole square and y2 minus y1 whole square. Next, we have the midpoint formula, that if any point is the midpoint of the line segment, then its coordinate x and y. X is equal to x1 plus x2 divided by 2 and y is equal to y1 plus y2 divided by 2. Right? And the distance of a point from origin. If O is the origin, then the distance OP is always equal to x square plus y square. Right? Now, what is the section formula? Right? Let me discuss the section formula. So, in the section formula, we can do it in two ways. If we have a line segment AB, one is A coordinates are like x1, y1 on the plane, and the B point, its coordinates are x2, y2. What is it? The coordinates of the one point A, the vertices, sorry, the coordinates of point A are x1, y1, and B point x2, y2. This is the kind of variables. Now, if any point P is there, if you want to find its coordinates, and it is given that the ratio m1 m2, this is m1 ratio m2, then we can find the coordinates of this point P, whose coordinates, the point P coordinates x, y, x is always equal to, we can make the arrows towards the side, m1 with x2 and m2 with x1. So this x is equal to, that is your here x1 m2, x1 m2, see interchange, x1 with m2 and m1 with x2 plus x2 m1 divided by m1 plus m. These are also written as mn also. I will write here in mn also. And what is this y? The value of y is again x1, y2, sorry, this is y1 m2 plus y2 m1, right? m1 plus m2, right? And sometimes if this ratio is given m, one is m and one is, then also we can write in this form. If it is mn, the ratio, one ratio is p, and the point one is m, another is n. So we will write here that x1n plus x2m divided by m plus n, and y1 with n1n plus y2 with m divided by m plus m. These are the ratios in which this point P divides the line segment AB. So this formula is called the section formula. Sometimes we are taking k ratio 1. What we are taking? We are taking k ratio 1. Here this ratio is k ratio 1. Then also the ratio will be the same. Like 1 is k and this ratio 1. This is 1 unit. Then also in place of x, the coordinates of x, they are your x1, 1 into x1 plus k times kx2 divided by k plus 1, right? And same y also, that is y1 plus k y2 divided by k plus 1. Just like m1, m2, this is also the way. So anyway you can opt. So let's discuss. After that, we have also discussed about various lines. In the last lesson, we have discussed and we have solved the exercise also, that is third exercise. We have discussed the equation of the line, that y is equal to equation of a straight line. Equation of straight line. Straight line, we have studied that y is equal to mx plus c. We have discussed so many examples. We have discussed the equation parallel to x-axis, equation parallel to x-axis, equation of line parallel to x-axis, parallel to x-axis, parallel to y-axis, parallel to y-axis, and we have also discussed so many relations like slope m1 into m2 is always equal to -1, two mutually perpendicular lines, right? If two lines are mutually perpendicular, then their product of their slope is always -1. So we have discussed so many ways of solving these equations. So let's discuss in chapter 3 the equation of lines. The coordinates will be, we are doing the exercise, midpoint of the line joining 2 points, the equation of the straight lines. Then we have also discussed the equation that px plus qx plus r is equal to 0, right? So here we have one example. Sketch the lines y is equal to 5, y is equal to 0 and y is equal to x. Y is equal to x on the same axis. Describe the triangle formed by the triangle. One example is being given. They are saying sketch the lines. 3 lines are given, right? Y is equal to x. sketch a triangle. Question is sketch the triangle x is equal to sketch the line y is equal to 5, the line x is equal to 5, y is equal to 0 and y is equal to x. Y is equal to 0 and y is equal to x. So here we have a xy plane, right? So on x-axis, this is the equation of x-axis, right? This is the equation 1 equation, and then x is equal to 5. 1, 2, 3, 4, 5. This line is the line x is equal to 5, right? This is the equation of line parallel to. Here the points are 5, 0, and one more line, that is your y is equal to x. So y is equal to x. This is the equation y is equal to x, right? Like 1, 1, 1, 2, so 2, 2, 3, 3, so 3, and here it is what? 5, 5, right? This will be 1, 2, 3, 4, and 5, right? And this is the area here. This is always 90 degree. This is the area which we are. This is the equation y is equal to 0, and this is the equation x is equal to 5. Right? This is the B. These are the points. So triangle obtains the isosceles right angle triangle. This is the isosceles. This is also 5 units here. This distance is also 5 units. This distance is also 5. And this is also, so it is the triangle form. Triangle form is an right angle isosceles right angle triangle. Isosceles right angle triangle. Right angle triangle. Right? Then isosceles right angle triangle. Next we have one more example is there. You have to draw a line y is equal to x minus 1 and on the same axis. On the same axis you have to draw two lines. The two lines are next is one is y is equal to x minus 1. One is the equation y is equal to x minus 1 and another is 3x plus 4y is equal to 24. And 3x minus plus 4y is equal to 24 on the same axis. On the same axis. On the same axis. Right? Y is equal to x minus 1 and 3x plus 4y is equal to 24. So here, when we have to plot these two lines, how to plot these two lines? We can make some points y is already in terms of x. So we will have one box, minimum 2 or 3 values we will take, right? One is x, one is y. If we took the value of x as 1, y is equal to 0. If x is 2, y is 1. If x is 3, y is equal to 2. Right? So here 3 minus 1 is 2. These are the solutions which we can put on the graph. And same for this equation, if I am substituting here 3x is equal to 24 minus 20, either in x or in y, right? If we are going to take in terms of y, so I will write here 4y is equal to minus of 3x and y is equal to 24 minus 3x divided by 4. From here, we will find the values of this line. Again, 2 or 3 values we will take minimum. Okay, one is x, one is y. So here, take x is equal to 0. If x is 0, this is the much better way. If taking x is equal to 0, so what is y? Y is 8. Not 8 is 6. 6 4s are y is 6 here. Now if y is not y x is that it is 12, sorry 4. X is 4, y is 3. 24 minus 12, that is 12. 12 divided by 4 is 3. That is 3 here. Now again, if it is so 2 points are going to move, then sufficient also. Even infinite many points we can find. So here we have a graph. This is x-axis and this is y-axis. One is your x-axis, one is y-axis. So here we plot the points 1, 2, 3, 4, 5, 6, so on. First 1 and 0. X is 1, y is 0. This point here. X is 2, y is 1. X is 2, y is 1. X is 3, y is 2. One is this graph. With the help of scale, we can plot this graph. This is the graph of line y minus x plus 1 is equal to 0. This is y minus x plus 1 is equal to 0, or in another way, we can write in terms of extended x minus, it is x minus y minus 1 is equal to x minus y minus 1 is equal to 0. Same this graph, x is equal to 6, 0, y is 6. Another point is x is 4, y is 3. X is 4, y is 3. So here, this is the solution of these two lines where it intersect. So I am drawing here roughly. When you will plot on the paper, you will find this is your line, this is the equation of line, this is 3x plus 4y is equal to 24. This is the equation of line, 3x plus 4y is equal to 24. So we have here the next exercise. You have to plot some of the lines on the graph. And by calculating the given following pair of linear lines, state whether they are parallel, perpendicular, or neither. Right? So here some of the equations. Exercise, next exercise. Like take a few examples here which they have given. CV, you have to sketch these lines. One is like very first part, y is equal to minus 2. Take few parts, y is equal to second, y is equal to 3 x plus 5. Then take question number, okay, already 10th part, y is equal to 4x plus 8. Randomly you can check 13 1, 13 1, 13 1 is y is equal to minus half of x minus 2. Then take 16, that is 2x plus 5y is equal to 10. And take one more last part, that is 20th part, that is y is equal to 2 minus x. So you have to plot there. See, just 20 parts for the exercise here, but only I have taken 5 6 parts. 1, 2, 3, 4, 5, and 6. So we will take one by one these parts, plot their graph on the graph papers, right? So let's start here with the first one. Y is equal to minus 2. If we have a graph, this is x o x dash, this is y o y dash, right? Y is equal to minus 2. This is y is equal to minus 2. Line, this dotted line is the line y is equal to minus 2. Because here it is minus 1, it is minus 2, minus 3, minus 4. This line, this is the equation of line y is equal to minus 2. Y is equal to minus 2 is a line parallel to x-axis. Confirm. Last lesson we have studied the line x is equal to a is parallel to y-axis, and y is equal to b. Y is equal to b is a line which is line parallel to line that is parallel to x-axis. Please remember that x is equal to a is a line parallel to y-axis, and y is equal to b is the line parallel to your line y is equal to b is parallel to x-axis, right? So vice versa, you can remember it. Now this is the first question. Second is y is equal to, right? Second is second part, if it is let's 1, 2, 3, 4, 1 minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 1, 2, 3, 4. Now the second part, that is y is equal to 3x plus 4 and y. If x is equal to minus 1, so y is equal to, if x is equal to minus 2, x is equal to minus 2, minus 6 plus 5 is equal to minus 1. And if x is equal to minus 3, x is equal to minus 3, so y is equal to minus 4. Right? So how to plot the graph? First point is 0, minus 1 and 2. X is minus 1, y is 2. This is the point here. First. Second, minus 2, minus 1. X is minus 2, y is minus 1 here. Next is 3, 4. X is minus 3, y is minus 4. So here this is the, when we plot the graph, this point will lies on the, we will find that the same, all the solutions. How many solutions? A pair of linear equations in two variables. A pair of linear equations in two variables represents a straight line, and a straight line is having infinite many solutions. A straight line is having, on this we have infinite many solutions. So we are just finding here 2 or 3 points, and then we know that any 2 points or 3 points are sufficient to draw a line. 2 points are sufficient to draw a line. So this line is represented by this equation. This is a general equation that is we have discussed. That is ax plus by plus c is equal to 0. Right? So next one is again the same way. Let me discuss the another one. That is y is equal to minus 4x plus 8. Y is equal to minus of 4x plus 8. So what are the solutions? We will make a box, and in a box we will take with x. If x is equal to 1, if x is 1, y is equal to 4. X is 1, y is equal to 4. If x is minus, if x is 2, if x is 2, y is 0. These are the sufficient. How to plot this line? This line, here we have the graph. It was the graph of previous one. 2 points are more than sufficient. We can take the third one also. Before it, 1, 4. X is 1, y is 4. 1, 2, 3, 4. 1 is the point here. X is 2, y is 0. So this is all points will lies on the same line. If I am taking x is 3, x is 3, so y is minus 4. X is 3, y is minus 4. Here. See, these all points, they must lie here on the, and this is the equation of line. That is y minus 4, or we can write y minus plus 4x minus 8 is equal to 0. Right? In the same way, we have 13th part. 13th part, that means some parts they are in fraction. So in 13th part, what we have, 13th part, y is equal to minus of 2. So here in this equation we will cross multiply. First we can take the LCM. We can simplify it. It is equal to minus of x minus of 4, but then it is LCM here, and we can cross multiply. We have 2y is equal to minus x minus 4. Or we can write this equation in this form, that is x plus 2y is equal to what? Minus 4. Or what is the x? X is equal to minus of 4 minus of 2y. Minus of x minus, and here we can apply the, now here I am writing x in terms of y. In earlier classes, earlier examples, we are writing y in terms of x. So it hardly matters, right? It hardly matters. You can write both ways. So here we have x, y. When y is 0, what is x? X is minus 4. If y is 1, if y is 1, x is minus 6. Or if y is minus 1, if y is minus 1, so here x is minus 2. In this way we can find infinite many solutions. We can find infinite many solutions for these linear equations in two variables, right? In the same way, we have left with the 16th part and two parts. So here, this is exercise. Okay, I have raised one part is left. That is twice of x plus 5y is equal to 0. Now we can write in two ways. This part we can write in two ways. We can write in terms of x or we can write in terms of y. It is our option. When we have to sketch these equations, it is up to us whether we want to write x in terms of y or y in terms of x. Suppose here in terms of, so it is 10 to minus 5y divided by 2. This is x in terms of y, right? X is in terms of y and here y is in terms of x. Y in terms of x is again x minus 2x divided by 5. These are the same way anyone we will follow, and from there we can find the solutions, right? We will find the solutions from anyone. So if you are taking this one, x and y, if I am interested here, then I will put the value of here x, and here y I will put the value of y, like y is 0. If y is 0, if y is 0 here, then x is 5 first. If x is y is 1 or y is 2 here, y is 2 here, so x is 0 here. And if we have want to plot the graph of the line, if this is the graph x and y, x is 5, 1, 2, 3, 4, 5, this is the point 50, and x is 2. This is the graph. Even we can put the values here. This value will satisfy. So here when we plot the graph of the straight line, it will be in this way, right? So here we can find infinite many solutions. Because on this line there we have infinite many solutions. First, we will put the value of one variable, right? X, suppose x is 3 here, or x is 4 here. Notice y is, if y is 1 or y is minus 2, minus 3, 4, so on, so we can find so many values or infinite many solutions. So this is about this first question. Second question is calculate the gradient of the following. Pair is given. For the following pair of, now second question that we discuss here. We have to compare the here in the exercise they have asked. We have to compare the gradient. We have to compare the gradient of the equations, right? So we have given the pair of equations. Second question, you have to, in the pair of equations, we have the three things. Either the pair of equations they intersect each other, or the pair of equations they are parallel to each other. Like here, if two lines, if we've got two lines, first the two lines they may intersect each other, right? If we plot the graph on the, they may intersect. Second, they may be parallel to each other. If one plot you are plotting and another you are plotting here, they may be parallel to each other. And the third one, they may coincide. The line may coincide. These are the three possibilities. But after checking the, solving the, finding the gradient, okay. So here the pair of the equations they have unique solution, parallel lines. Here these are intersecting lines, intersecting lines. Here parallel lines, no solution, and here these lines they coincide, right? So here some examples I am writing here. Some pair, one is y is equal to minus 4, x is equal to 2. Like first, y is equal to minus 4, x is equal to minus 2. Or x is equal to 2. What about this pair? Y is equal to minus 4, y is equal to minus 4. See, if we have a graph, y is equal to minus 4, 1, 2, 3, 4. This one is the dotted line here, right? This is y is equal to minus 4. And x is equal to 2. 1, 2. This is x is equal to 2 here. This is your x-axis. This is your y-axis, right? So here, so these two lines, x is equal to 2 and y is equal to 4. These two equations, if we have to find their gradient, one line is having zero gradient, right? That is always parallel to x-axis, and one is having infinite gradient, right? So here, these two lines they are mutually perpendicular lines. These two lines are mutually perpendicular lines. So here we have again 12 parts to this question. Let me give you some questions to solve. Please note down, and as a homework you can do. Let's take 5 questions. 5. You have to just tell about whether they are parallel or perpendicular. First one is third one. Or I am giving the number in my own way. 1, 2, 3, 4, and 5. Let's take as a homework. Right? First one is 3x minus y. 3x minus y plus 2 is equal to 0. First, and its pair is 3x plus y is equal to 0. 3x plus y is equal to 0. This is the first one. Second, please write down second one. That is y is equal to 2x. Y is equal to 2x plus 3 and 4x minus y plus 1 is equal to 0. Right? Is equal to 0. So next, that is x plus 2y. X plus 2y minus 1 is equal to 0, and its pair is x plus 2y plus 1. X plus 2y plus 1 is equal to 0. Right? Same you have, one is y is equal to 2x minus 1, another is 2x minus y, 2x minus y plus 3 is equal to 0. Take one more part, that is, yes, x plus, or take it as y is equal to 2x, y is equal to 2x, and 4x plus 2y is equal to 5. Right? So here these 5 parts you can take it as a homework. So with this, thank you very much. God bless you all. Stay safe and stay healthy.